Hello friends, in today's video we will talk about power of study. Hope you would be able to answer following questions after watching this video. First question, what is the main difference between type 1 and type 2 errors? And second question, can we answer the significance of observation based on p-values? So let's start with the brief background of hypothesis testing before we start talking about the type of errors. Here I will be talking about hypothesis testing in brief, as I have already uploaded a video on hypothesis testing. I will share the link of that video in the description box. If you want to see the hypothesis testing background in full description, you can go to my video and watch. So what is null hypothesis and how it is different from alternative hypothesis? These two hypotheses by these two hypotheses we consider the effect of two groups, whether the effect is existing or not. Let's assume that we want to see the effect of two drug A and B on the reduction of serum glucose level. Let's assume that we want to see if the difference in reduction A is existing or not. So we can have two type of hypothesis. First, null hypothesis, where we can assume that no difference is there, and opposite to that we can also consider alternative hypothesis, where we can consider that difference is there. So for null hypothesis we will make an assumption that effect of drug A in reduction of serum glucose level is equal to effect of drug B, and in alternative hypothesis we will consider that effect of drug A is not equal to effect of drug B. Here in null hypothesis we assume this, and by nature always we try to reject this null hypothesis to prove that there is a difference. And in alternative hypothesis we attempt to prove that there is a difference. And if we are not able to reject this alternative hypothesis, if we are not able to prove it, then we need to reject this alternative hypothesis, which would mean that effect of drug A is equal as the effect of drug B. So hope it is clear now. Let's talk about the nature of assumptions, what we have in null hypothesis and how these are opposite to the alternative hypothesis. Let's see, if null hypothesis assumes that a x is equal to y, then alternative hypothesis will say that x is not equal to y. If null hypothesis says that x is less than equal to y, then alternative hypothesis will say that x is more than y. Similarly, if null hypothesis says that x is more than equal to y, then the alternative hypothesis will assume that x is less than y. Let's quickly construct both hypotheses for one objective. So we have an objective. We want to prove that mean body temperature of an adult is not 98.6 degrees Fahrenheit. So what would be the associated null hypothesis to prove it, and what would be the alternative hypothesis to prove it? So as we know that null hypothesis is always based on the opposite sense for the main objective we want to prove. So here we are talking about the temperature is not 98, then null hypothesis will be constructed like temperature of mean body temperature of an adult is equal to 98.6 degree Fahrenheit. So here we will say the temperature is equal to 98.6, and opposite to it, in alternative hypothesis we will say that the temperature is not equal to 98.6 degree Fahrenheit, which would be in line with the objective of the experimentation. So now talking about the statistical power of study and beta. See, for any null hypothesis, there can be two chances. The null hypothesis can be true and it can be false. So for the condition where null hypothesis is true and we do not reject null hypothesis, then it would be our correct decision. Similarly, if null hypothesis is false and we reject null hypothesis, then it is always also a correct decision. But what happens when we know that the null hypothesis is true, but we have rejected it? So this will be the incorrect decision where we are rejecting null hypothesis wrongly. Similarly, if null hypothesis is false, but we are not able to reject it, so it would be again a wrong decision. So by these two decisions, these wrong decisions, we can conclude the final result of experiment which would be not correct. So these two decisions are associated with the errors. So these are two errors, type 1 and type 2. If null hypothesis is true and we reject it, the associated error is termed as type 1 error and denoted by alpha. Similarly, if null hypothesis is false and we do not reject it, then the associated error is termed as type 2 error and denoted by beta. Let's talk about both of these types one by one. Type 1 error. What does type 1 error means? It means we have incorrectly rejected the null hypothesis. It is denoted by alpha, and alpha is the probability of type 1 error. So what are the causes associated with type 1 error? So any expected or unexpected biasness in the experimentation can lead to type 1 error. And what does type 2 error means? Type 2 error means we have failed to reject null hypothesis when it should have rejected. So it is denoted by beta, which is probability of type 2 errors. Similar to the type 1 error, cause of type 2 error is also the same, and it happens due to the expected or unexpected biasness in the experimentation. Coming to the power of study. What is power of study? Let's consider that experimentation in which we have taken two groups, and within those group a difference is present which is correct, and ideally we should reject the null hypothesis. Means the difference truly exists. This is the ideal condition when we should reject the null hypothesis because difference is there. So if difference is there, power of study will signify that probability of finding the difference between those groups, if it does exist. In simple words, we can say that power of study is ability of study to avoid type 2 errors and is represented as 1 minus beta, where beta is probability of type 2 error. So high power of study advocates higher significance of results. Beta value less than 20% represents higher power of study. 20% beta means 0.2. Based on beta value 0.2, if we calculate the power of study, which is 1 minus beta, then the power of study will be 0.8. which will be considered as 80% power of that study. So it is considered that for a good quality results, power of study should lie in between 0.8 to 1. Means the power of study should be more than 80%. And what does it mean that power of study is 80%? In simple layman language, we can say that a study that has 80% power means that the study has an 80% chance of the test having significant results. In previous slide we discussed about the power of study. What is power of study? Now we will talk about how we will determine the power of study. What are the factors which are associated with power of study? So power of study depends upon study design. As we know, power of study can be determined by projection based on study design even before starting the study. So if we will plan our study in that way, considering the factors which will be making the power of study higher, and will avoid the factors which can cause the reduction in power of study, we can lead to a very good conclusion, and our study would be considered as a quality study. So let's talk about the factors associated with higher power of study. So the most important factor associated with the higher power of study is sample size. So just consider two experiment in which in first one we have only 5 patients, and in second experiment we have 500 patients. So two drugs are evaluated in both of the experiment. So in first experiment where number of patients are only 5, if study that experiment lead to one conclusion, and the another study which has the patient sample size 500 leads to another conclusion based on the same hypothesis and the same objective, which one we will rely? I am sure that we would be thinking about that the number of patients are higher, then we will go with the sample size. So yes, you are right, we will rely more on the study where the sample size is higher. You can see that 5 and 500 around 100 times higher. So power of study would be higher where the patient size is 500. So is power of study is somewhat associated with sample size. The second factor is effect size. Effect size simply means difference between the group. Let's talk about the reduction in blood pressure by the two drugs. If one drug causes reduction of 5 mm of Hg, and the another drug cause reduction of blood pressure by 15 mm of Hg, then the difference between group would be 10. Here the effect size would be 10. Higher the effect size, higher would be the power of study. Similarly, the third factor, precision of the results. Precision of result are described by the deviation, standard deviation of that value. Let's say if we talk about mean or median value of something like overall blood pressure of 100 patients, and the effect size is let's say the outcome are reported for two groups having 100 number of patients in each, and the mean effects mean blood pressure of the group A is 85, let's say 85 mm of Hg, and group B has the overall blood pressure, mean blood pressure 88 mm of Hg. There here the effect size would be 88 minus 85. So effect size mean difference in the reduction of blood pressure would be 3 mm of Hg in that experiment. But what about the precision of that study? How much that mean 85 and mean 88 deviate from its mean value? So this deviation may cause overall power impact, bad impact on power of studies. Lower the standard deviation, higher would be the power of study, because lower the standard deviation, precision of result would be higher, and precision of result would be associated with higher power of study. Similarly, talking about the factors associated with lower power of study, so you know that high power of study is 1 minus beta value. So beta value is directly associated with the power of study. Power of study is, let's say beta is 0.2, then power of study would be 0.8, and 0.8 means 80% of power, which is considered as a good power of study, and study is considered as quality study. So here a likelihood of type 2 error will reduce the power of study, or indirectly we can say that any biasness which may cause wrong rejection, which may cause type 2 error, will lead to lower power of study. Then talking about the p-value and its interpretation. What is p-value? P-value is a measure of disagreement of observed data with null hypothesis. There is a caveat associated with p-value. P-value concept only comes into picture when null hypothesis is true and logically have no value if null hypothesis is not correct. Lower the p-value will indicate that more disagreement, means we can reject null hypothesis. More disagreement can be explained like the drug A and drug B effects are not equal, and the disagreement of effect, or let's say effect size, is higher. Higher the effect size, lower will be the p-value. Simply in the layman words we can say that there is very less chance that the groups considered are same in producing the effect. That means there is a short difference in the effect. Higher p-value means less disagreement, means there is very high chance that the groups considered are same in producing the effect, so fail to reject null hypothesis. Here we are talking about low p-value and high p-value. So what is the threshold? How we can consider that which value is low and which value is high? For this we have talked about this precision and this threshold with the researchers. So with consent of researchers, the researchers have accepted that only less than equal to 5% probability of wrong rejection of null hypothesis is acceptable, not more than 5. So here we are talking about wrong rejection of null hypothesis. What does it mean? Wrong rejection of null hypothesis means type 1 error, which is denoted by alpha. So if we consider this threshold, if p-value is less than equal to alpha, that means it is statistically significant. If p-value is more than alpha, it means that it is not statistically significant. Although the effect size is good enough, but it would not be considered as the statistical significant difference. Please do note that statistical significant does not mean clinical significant. Clinically significant can be different from statistically significant. How it differs, we will be talking about this in our next video. And now I want to conclude that the p-value less than equal to 0.05 means statistically significant, and p-value more than 0.05 means not significant. So we already know that this 0.05 comes from the 5% for the alpha value. So alpha value less than equal to 5% is statistical significant, and alpha value more than 5% or 0.05 is considered as statistically not significant. Here I have a question for you. Can we say that only p-value is enough to conclude an observation or trend of outcome? Can we decide that the difference is good enough to conclude that the drug A is superior than drug B, or we should also talk about the clinical significance of that difference? Just try this question with by yourself, and in my upcoming video I will be discussing about it. Thanks. Hope the video would be useful for you, and now you are able to answer the both question which we have discussed in our initial slides. So thanks and bye. We'll meet you soon.